So here we have with aromatic diazonium salt. This is not in syllabus as has been said, but little bit of this we should do because it may come in some other way or in other exams. Okay. So aromatic diazonium salt is this AR or benzene ring N triple bond N and then X minus. This is called benzene diazonium salt, or if this is anyway halogen, benzene diazonium chloride. In your book, it may be given as benzene ring, then N2 plus X minus. So how is this compound produced? That has been discussed, like aniline, when it is treated with nitrous acid at a very less temperature, 0 to 5 degrees Celsius. 0 to 5 degrees Celsius. This nitrous acid is produced inside the reaction mixture by using NaNO2 plus HX. NaNO2 HX produces HNO2, and then this one reacts to form this one, benzene diazonium salt plus water. Now, if we take aliphatic amine, in this reaction, then what happens is we will get this one. We'll get this one, but aliphatic diazonium salt is highly unstable, and it breaks down into alcohol. It breaks down into alcohol plus HX with the release of nitrogen gas. But aromatic one does not break down because it is stable. And stability can be explained by resonance. So let us draw the resonance structure of this. So what will happen is in the resonance, this electron will go this side, and one of the pi bond will break and it will come over. So initially there is a lone pair here. Okay, and this one will go, so we get this term. Here no need to write this X minus. So this is going now, this part will be plus, this nitrogen will be as usual plus, this nitrogen will become minus. So resonance has taken place, and in this way this resonance will get more structure. The next structure, what will happen is this pi will come here. Then again this one will come here. So in this way resonance takes place, and that's why aromatic diazonium salt is stable. Such resonance cannot take place in aliphatic diazonium salts. Okay. Now as far as reactions of diazonium salt is concerned, reaction of diazonium salt is concerned, uh, you have to know that this diazonium group can be replaced by so many other groups, so that those reactions you should know. So one reaction which is there is Sandmeyer reaction. If the aromatic diazonium salt is treated with your CuCl in presence of HCl, then this diazo group gets replaced by chlorine. Here it is also applicable for Br. If you take here CuBr, HBr, then here it will become Br. If you take here CuCN, HCN, then it will be replaced by Cn. And of course, there will be liberation of nitrogen gas. And this reaction is called Sandmeyer reaction. Suppose you want to replace this group by say OH group. Replace it by OH group. Then you just have to warm with water. If you warm with water, then this becomes plus N2 plus Hs. So replacement by H has been increased. Suppose you want to replace it by H. If you want to replace it by H, then you have to treat with ethanol or H3PO2, phosphonic acid. Then it gets replaced by H. That is, it becomes benzene. So in this way, you will see in your book. Now this is nothing much to explain. How can we replace it by NO2 group? How can we replace it by I group? So all this you have to study. For example, let me tell about I. If this diazonium salt is warmed with potassium iodide, then we get I. How to replace it by F group? How to replace by NO2 group? All this type of reaction you will find in your book that you can just do, because it may be required in your competitive examination, and these are very important as far as organic conversion is concerned. So one thing about all this reaction is that in each case, there is liberation of N2 gas. There will be liberation of N2 gas. So in the chemical reaction of aromatic diazonium salts, in all these cases, there is liberation of N2 gas. There is another type of chemical property of diazonium salt where there is no liberation of N2 gas. So such chemical reactions of diazonium salts are called coupling reactions. coupling reaction that you have to do. So I'm giving you one example of coupling reaction. So the aromatic diazonium salt plus phenol, and they offer reaction at this para position with respect to this. So here we take the product. So this is called this is the name of this compound, in common name is called para-hydroxy-azobenzene. Para-hydroxy-azobenzene. This is a azo group, and this group brings a lot of color. I mean, this color, it has intense color. This compound has got intense color. And because of their intense color, these compounds are used for dyeing clothes. So this coupling reaction happens with phenol, or it also happens with aromatic amines coupling reaction. And you can see here, unlike these reactions, here nitrogen gas is not liberated. Nitrogen gas is not liberated. So basically, this much we have in case of this amine chapter. So go through it properly. We will be discussing your doubts or some question answers in tomorrow's class. Till then, have a good day.